I thought I would kick off the discussion by asking the three panelists who just joined us about some of the application areas that you're considering, and then we can have a discussion about possibilities and challenges and so forth. So let me start with you, Paul. So you lead the surgical robotics business at Medtronic. What do you see as the potential for surgical robotics to dramatically improve the state of surgery?
Well, first of all, thank you. It's great being on stage with all of you. Just to clarify, the Medtronic surgical robotics business is actually an incubation business. So we've not yet launched this system, but it's a fairly significant effort. The interesting thing about surgical robotics specifically, not medical robotics more broadly maybe, is that they're almost all entirely teleoperative systems. So there is no autonomous action by the robot in surgery. There are some small exceptions to that. But what those systems do is allow for less invasive surgery. So for abdominal surgery, a robot gives the operator, the surgeon, the ability to have more dexterity down inside the body, because they have 7 degrees of freedom in these wrists down inside the body in these small instruments. So the future for those things are pretty obvious, right? As more competitors enter the market, the costs will go down, the technologies will continue to improve, and we'll see in surgery today, only 20% of abdominal surgeries are done what we call minimally invasive, and the opportunity will be worldwide for those to get better. But the interesting thing in regards to the conversation we had today, I'll say two other interesting things.
Okay.
One is that, because these robots, as Dr. Kelly said to me when he came to visit us a couple of months ago, he said, so your robot is just a big sensor. Because the reality is, the surgeons are operating it, but the robot knows all the places that it is during every step of the operation. So there are some very interesting implications in relative to sensing what that robot does in every other part of the case and adding that to all the sets of data that might inform us as to how we can improve surgery. And I could talk all day about the ways we might improve surgery. The second thing I would say, so one, robots will get cheaper and better sort of iteratively, and so we'll get better penetration in minimally invasive surgery. Secondly, these sensors will do smart things. And I would say the third thing we'll see, and I think the presentation that was just done was very interesting in that I think we'll start turning around and looking away from the patient. Because right now, we're adding robots to the most difficult, most skill-based thing in the operating room, and that's the relationship between the patient and the surgeon. But what's happening behind the surgeon is lots of more mundane tasks that can be augmented with surgical robotics or with robotics.
Terrific. Of course, the robot is both a sensor and an actuator, right? So that's at the end of the day
I think John was using that tongue in cheek, but yes, of course.
No, that's great. That's great. So Gaurav, let me ask you the question. Your lab does a lot of research in mobile robots. What kinds of potential applications are you folks envisioning for your robots?
First, thanks very much for inviting me. It was a really fun day. So we're excited about lots of different kinds of robots, but I'll pick one example that we've been fired up about for the past decade or so. We've been working on underwater robots. So there are 3 sort of frontier technologies for robotics. One is space, one is the world within the body, and the third, I think, is the deep ocean. These, if you will, they're physical frontiers. Of course, there are many intellectual frontiers. But I think these are really 3 physical frontiers for robotics, to literally go places where we currently aren't that good at going. And the 3Ds play equally well for underwater systems. They maybe don't quite play as well for in the body. I suspect we probably don't want to say dirty, but certainly it's dangerous in some ways. So we're quite excited about underwater systems. And simple problems, or otherwise simple problems, seemingly simple problems, take on a life of their own once you pick a challenging domain like this. So I'll give you an example. a core capability for mobile robots is the ability to navigate from A to B. Very often we either we take this capability for granted because there are groups that develop techniques to do this in a good way, we build in their work, or you have to invest a certain amount of time building a navigation stack. Underwater, there's the curious problem where if you don't take active measures and you turn around and walk away, when you come back, your robot actually isn't where you left it. This is a startling and annoying problem, one that you don't face when you have a robot in the hallway, for example. Now, this is a problem and an opportunity because if you have access to communication, and I'll come to that in a second, but if you do, and you have access to people who do ocean forecasts, then you have some predictive ability about where the ocean is going to take your robot. And so we've spent some time working with people at NASA JPL who generate ocean forecasts for us, and we're able to incorporate these into navigation planning for our vehicles. So it's an interesting old problem, sort of problem of navigating, but it's navigating under certain kinds of uncertainty, and the explosion of data and new models has sort of created this ability for us to actually be able to do this for real. We're able to put vehicles in the ocean for weeks on end and have them navigate reliably underwater. The second kind of way the problem manifests itself is that communication is a challenge. A commercially available modem, off-the-shelf, sort of cheap modem for underwater vehicles will give you a few bits per second, or a few tens of bits per second. And I said bits, just so people in the back are so that's a small data problem. You want to squeeze a lot of data down a very small pipe.
Yeah.
It's exacerbated by the fact that if you want a good position fix, you have to come to the surface. And so you spend energy doing that. So otherwise, ordinarily simple things like fixing your position or communicating costs energy and time. And so if you fold those into your cost function for whatever task you want to achieve, the costs associated with those tasks have complex landscapes now as a function of these constraints. And so again, sort of problems in planning take on a life of their own because of these odd constraints.
Right.
So it's an exciting frontier area. It's a fun area to work in, and it's it's a frontier. There's a lot to learn. So the domain I think is challenging and interesting.
Yeah, lots of interesting technical
lots
problems,
of interesting
right?
applications.
So great. So Grady, let me ask you also just to get the same level of understanding of application domains. You've been thinking a lot about many different industry applications of robotics. For those of you who may not have seen it, or who hopefully you have, the Pepper robot outside is an example of a recent robotics kind of revolution that's happening in retail and other kinds of human robotics interaction kinds of things. But Grady, you've been thinking about a number of different robotics applications. Where do you see the sort of the high value economic and social applications?
Well, I think there's an easy and obvious answer, but I'm more interested in the hard and interesting answer.
Okay.
The easy answer is, as I look across the range of every place our enterprise customers are in, or beyond our customers, every industry seems to have some degree of robotics for which there is an opportunity. From farming to manufacturing to surgery to retail, every one of these places you can begin to see an economic case. That's the easy and obvious answer. The harder and more interesting answer, I think, lies at the touch point of big data and human interaction that's then mediated by a cognitive system. Imagine then a system that is in the world, has models of the world, and interacts with the world, and yet has the intelligence and common sense of an AI. It's that space and intersection I think is quite interesting. It's what I call the socially intelligent cooperative robot. And the Robonaut 2 is exactly a great example. Imagine a scenario for the Robonaut 3. It's outside, it reports back to me, Grady, I see a 100% failure in unit AE35 in 72 hours. Anybody catch that reference? And what I would then say is, Robonaut, can you explain that to me? And have a dialogue where it becomes an extension to me, but also a collaborator with me. So I think the economically and socially interesting places are where I have this device that is socially intelligent, that's in the world and acts in the world, but collaborates with me. Elder care is a great example. we look at so many places in the industrialized world where, frankly, there is this population bubble and we have few people to attend to the aging population. There is a space where a cooperative robot could make a transformation, not just economically, but just, personally to individuals.
Terrific. So it's very broad, right? You actually touched on a number of capabilities that I wanted to ask all of you about. The examples that we see in robotics, especially the ones that you showed, Ron, it's obviously a very complex mechanical, electrical system. The part that's not clear to me yet is how does it use or does it use very sophisticated software, AI, machine learning, all of the techniques that we've been talking about all day today. How much of that kind of, let's call it cognitive systems or cognitive capabilities are built into the kinds of robotics applications that you're all thinking about? And I welcome any one of you to step in and answer this, but we'll start with Ron.
So in the Robonaut case, we don't have very much cognitive ability. We have places where we have automation, where it makes sense. For example, when you saw the robot climbing across the handrails of that space station mock-up,
Yeah.
it used vision and some relatively simple vision algorithms, and it used force control, basically what I call behaviors, to be able to perform its task. We focus, and because of where we are in the space program at this time, working with low Earth orbit for the most part, we focus more on capabilities and supervisory control than autonomy. We definitely want to move towards autonomy and cognition being related to autonomy, but we have focused more on supervisory control right now to develop those skills that can then be later, once they're proven out, be used in a more autonomous system. So some stuff I didn't show today, when we're going to go interact with a tool, for example, we will use things called affordance templates, and I imagine it's probably familiar to some people in the audience, where we have a model of the system, and it also gives you information about what can that device do for you. Like the affordance of a RFID reader is that you can grab it in a certain way, and then you can scan and get data out of it. So we use those tools right now to perform our task. The supervisor will verify the initial registration between the model and the actual item in the environment. So it makes it easier for your machine vision because you have a little bit of help there.
Yep.
And then as we perform different subtasks, at each point we have the supervisor verify that they're doing it properly. And that'll work fine in even supervising from low Earth orbit to low Earth orbit, where it can vary from a half a second to 2 seconds of delay based on the locations of the TETRA satellite system. But we do want to move more in this direction of autonomy and cognition, because once there's a 40-minute delay on Mars, we're doing things like the JPL folks are doing them, or when we're doing more complicated tasks like maintenance, we need to give the robot more ability so it's not waiting for every step from
Yep.
Earth 40 minutes later.
Yeah. Exactly. It sounds like there's a level of perception that is going on the device, right, on the robot, but there may be some more complex cognition types of capabilities that's outside the device, in the cloud, so to speak.
Well,
and there's some kind of interaction that has to happen between
So
the two.
right now it's the human providing a lot of that cognition, but as a step towards the Martian mission or the other missions that are further out there, there can be other cognition techniques that will take us there.
Very good. Any other comments on that?
So in our work, we tend to be interested in significant levels of autonomy for these underwater vehicles.
Okay.
So we run missions where the vehicles are in the ocean with no human contact for a week up to a time, making all decisions autonomously.
Yeah.
In terms of sort of what kinds of data-driven or machine learning approaches help, we recently completed a very interesting project where we worked with a team up at, or just not far from here at the Monterey Bay Aquarium Research Institute, Embodied, on designing a technique where marine microbiologists could specify what kinds of microbes they were interested in sampling in the ocean. And using a decade-old data set on previous surveys that underwater vehicles had performed, we learned a model of where it was most likely that water samples would yield those kinds of microbes. And then the vehicle basically was let go, and over a day long made its own decisions about where to go and where to sample, and come back with the kinds of samples that would be appropriate for the scientists who were running the mission. It was sort of an interesting loss of control for people doing biology to hand a vehicle to a group of computer science people clearly don't know any biology and say, here, bring me the microbe I care about. And we came back with the kinds of microbes they had in mind. And so that's the full gamut of using old data, building a model, then doing online decision making under uncertainty, folding in ocean forecasts to inform the navigation problem.
Very interesting.
And really the operator is completely hands off for a day, to the point where you show up in a ship at the end of the day at a rendezvous location and hope the robot pops up out of the water. It does. So that's an example of very much a sort of I think the kinds of systems you're talking about today, using the cloud, and but in a very sort of different domain than what many might think about.
Very good.
I guess I'd add one thought to that. I think that like the robots in space we're talking about, I think that there's when it's teleoperated, obviously there's not a lot of, there's no autonomy and not a lot of cognition. I think in any of the, I can't speak for all of the surgical robots that are available, but I think very few of them have any cognitive ability. But I think that we need to start thinking about these robots as sort of one element in a system, let's call it the operating room. And I think the question we have to start asking is what cognitive abilities do we add to the operating room where the robot is an element? And I think that sort of opens up our opportunity to think about things we might do, and it also allows us to think about the things I said previously, and that is, if you look away from the patient, you know, the problems in healthcare aren't always how do you improve the care that you're bringing to the person that you're treating, right? The question is, how do I get care to the people that we're not treating at all? And a lot of that is cost-driven things, and a lot of the cost are the things that are happening in the operating room behind the patient, right? So if there are things that we can do to improve the efficiency around the robot, whether it's using the robot or not, as part of that, I think we'll find that we can provide some real benefits to the healthcare system. And again, thinking a little bit more broadly, thinking about the operating room as a system with the robot in it.
The reason I like the term embodiment is that it becomes a superset of traditional robotics, because I could view that the operating room is an embodiment of a cognitive system, because there are many pieces that must collaborate with one another. And now this leads us to the challenge of many agents which have their own various capabilities and responsibilities interacting with one another, and that system is something that I can see as an embodiment of the cognition.
And the risk management challenges and the regulatory challenges when you're not touching the patient, those barriers are a lot lower.
So one question NASA started to ask itself is, if we have, once crew is going far away, they can't rely as much on our mission control folks because of the time delay for them also. So does the embodiment go into the space vehicle? Does the embodiment go into the robot? Or what's the right mix? And that's something I don't think we know yet.
Right. Yeah, that's a system engineering problem.
Yeah, and interestingly, we are looking at many different environments in which cognition can be embodied. It could be, a boardroom, or an operating room, or a classroom, right? Different kinds of rooms where there's different tasks and different kinds of scenarios and different kinds of data that's being used for decision making of various kinds. So all of those are great examples of embodiment. So, and I just want to mention also that John Lade's example video that he showed earlier is a very good example of some of the learning tasks that are being done by robots. Even some of the more advanced learning tasks being done by robots, which is an embodiment of cognition, right? I'm going to ask one more question, then I want to open it up to the audience. There's everybody who talks about embodied cognition kind of tends to focus on humanoid robots, and there's something really interesting, maybe even magical about humanoid robots, and what makes humanoid robots prime candidates or scenarios for embodying cognition? What are your thoughts on this?
Well, depending upon your faith belief system, we've either been around other humanoids for 6,000 years or tens of thousands of years, depending on your belief system. And we have shaped our world to be of humanoids. Therefore, what excites me about this notion of embodied cognition is, in effect, we are at a next generation of human-machine interface. Rather than a mouse or a screen, I want to interact with something that is like me. It's what we've done pre-computing. We're circling back to that. So the attraction of the humanoid embodiment is that it is the ultimate natural interface.
I think there's a lot to be said about the richness of data that can go back and forth between a human and a humanoid robot. I mean, you have similar limbs, you have similar sensing. When you can go back and forth through natural language, and then you can communicate in very subtle ways between the two that you couldn't communicate with a non-humanoid system. I think humans to humans have the most complex relationships around. The more human-like the robot is, the more you can take advantage of that similar type of scenario.
The world around us is designed for humans, so the robots can actually do something meaningful in there as well, right? So any other comments?
I think that it's interesting in the medical space. I think what you see is when the patient's awake, it's more humanoid, and when the patient's asleep, it's not. It's more utilitarian.
Yeah.
And maybe that kind of speaks to some of the very interactions we're thinking about here.
I think in your world, it doesn't matter, right?
No,
It can be a square box, right?
Though I think if you do manipulation tasks, where, for example, you want to disassemble a rig in the ocean, so work that we're just getting into, then the kinds of machines that suddenly become relevant are machines like the Robonaut. And in fact, there's a couple of projects spinning up where there's some interest in having a sort of a torso manipulator system attached to a underwater vehicle. And so if you do manipulation tasks, if they're going to be teleoperated, then some of the same kinds of constraints come in, and people think in terms of a bimanual system and so on.
Okay, very good, very good.
Yeah.
All right, let's open it up. I see a question over there, so can you please pass the microphone?
Stephen Crane from Stanford. So I come more from psychology and neurobiology, so maybe you can help me translate this. When you talk about embodied cognition, I'm curious what you mean, because on the human side of things, we're usually talking about our bodily states informing our emotions, which underlie our decisions and analyses and actions in the world. And so when you're talking about robotic embodied cognition, to what extent is that similar or different from human embodied cognition?
Got it. I'm inspired by Dr. Rodney Brooks's notion that true intelligence can only come in the presence of embodiment. And for me, I mean that in a very general sense. That is, it is a system that is in the world, builds models of the world, has models of itself, and acts in the world. And so that's what I mean by embodiment, which is why it's a term I use that can be from a humanoid robot to an operating system. I think it's expressive enough to cover that. Does that make sense?
Question there, back.
My name's Lou Freund from San Jose State University. You were just talking about how important it is, or how pleasant it is, to have these robots sort of look like us. But I noticed in the lower body of the NASA robot, you articulated the legs quite differently than ours. I think you have 3 joints in each leg. And I'm wondering why you did that on the lower body and not some similar thing to the arms.
Manipulation tasks that we perform on the ground are pretty similar as we would perform on orbit. You still need to have human-like hands and arms that give you a reasonable workspace. But we didn't evolve in space. So if we had, our legs would be nothing like they are now. Using legs that are designed for walking in space doesn't really get you anywhere. As a matter of fact, the astronauts spend most of their time putting their legs in foot restraints just to anchor themselves because their legs aren't very useful. And when they move through the space vehicle, through the space station, they actually fly like Superman. They don't climb. But we are required to not have a massive robot floating through the space station or flying through the space station. So we maintained our inspiration with nature, but more for something that was climbing than for something that was human-like, because human-like legs just aren't very useful in space.
Wow, great answer.
Fair. Other questions? There's one here.
So this last question, and also I think the last question you guys discussed is inspired by this. This reminds me of something Bob Moog, who's famous for inventing the Moog synthesizer in the 60s, early 60s, kind of similar problem that he had. So they first invented this idea of an analog synthesizer that would create music via synthesis. And the question is, what kind of interface would you create that's natural to create sounds that don't exist? And at first it wasn't the keyboard that became very popular, it was the patches and different kind of devices, and then the keyboard ended up being a very popular form, and today there's other types of interfaces that are very different than what Moog originally envisioned. So I guess what I'm trying to say is perhaps this evolution that we've come up with, this human form, as we think is maybe optimal for Earth, or maybe on most trees or buildings or modern lifestyle, might not be an optimal solution, but perhaps if we design some sort of genetic algorithms or some simulation, we could come up with designs that we never thought of, and similar to the ways that DeepMind and other companies using reinforcement learning have discovered strategies in playing games or other things that come up with designs that are very, very novel. So I think maybe you guys have something interesting to say about that.
Yeah, I just have to mention that the diversity of life forms on the planet, right, is a testament to all the specialized designs that you can possibly think of for the different habitats, right, and for the different kinds of tasks that each of them does. So I think, the point is well taken, that it depends really on the task at the end of the day and the environment in which the task is being done, that the design of the robot should be influenced by that. But if you have any experience designing, robots for specific tasks and environments, I think it would be great to.
Ron used an important word, which was trust. And I think that one of the things a humanoid robot now offers is unless you get too close to the uncanny valley, there is a level of comfortableness and trust that one can have there. And the moment you begin to deviate from that form factor, it becomes a little bit strange. So I think we're going to see a coevolution. And at least insofar as the category of things that interest me at the moment, which are the cooperative robots, insofar as it has a humanoid form, I think the humanoid form does have some emotional value in regard to getting trust.
I would also say that I think you're right, Guru, that the task one is trying to perform in a teleoperative system needs to be mirrored by the user interface. So if you're doing surgery down in the body and you need a wrist, well, you sort of need a wrist at the user interface level, especially if you're trained using your wrist to do surgery, right? But there's always the question, well, why am I doing? So the question maybe shouldn't be, what should the user interface look like? The question should be, what am I trying to do at the end, and is there a better way to do it? And I think that question should always be asked, and there often is.
Yeah, agreed. Question over there.
Ellen from People-Centered Internet. I want to acknowledge Ada Lovelace Day and bring forward the idea that body language is 86% of the ways that we communicate as humans. And so as we talk about embodied cognition, how much are we actually looking at the language of emotions and love and caring? And these things will be very, very important if we are looking at robots that would care for our elderly or our children. So I just want some comments on how much work are we actually doing in body language and the trust building that's actually necessary to establish that.
I can start that.
Come up again, yes, please.
So another person from the MIT Media Lab was Cynthia Brazil, and she had a robot called Kismet, which had all sorts of facial muscles that could be used to express the robot's emotions or simulate emotions that are appropriate for the simulation, for the situation. So I think, as robots move more into that type of industry, the caring industry, I certainly think the technology is there. It can be augmented by the ability of a cognitive system to be able to read a person's emotions based on all sorts of good previous information. So I see that opportunity existing, and I don't see any real technological barriers there versus any other thing we've been discussing today.
To echo the philosophy of Manuela at Carnegie Mellon, she believes function is more important than emotion first, and I'm absolutely in agreement with that. But I would add then that emotion becomes a context for interaction with an embodied robot. So especially in the case of elder care like you described, for a robot to be able to sense the emotional state of the person to which it is cooperating should be part of the context of changing its behavior. And similarly, if I'm interacting with such a device, if I'm at a call center or retail store and I'm expressing frustration or curiosity, that's part of the context that such an embodied system should react to. I think there's tremendous opportunity for some really fascinating interdisciplinary research on this one. We need to, generate the job of Dr. Susan Calvin, and we need these robot psychologists. I'm very disappointed, by the way, that nobody laughed at my 2001 joke, except you.
I caught that.
Yeah, good. I'm giving all these science fiction references. I'm sorry, Dave.
We haven't brought up the 3 laws either.
Since you brought up Manuela Veloso, I think I'm going to ask the next question and then go back to the audience. These challenges that we've defined for ourselves as a community, right? There's the RoboCup challenge, which Manuela has been championing, but there's also the DARPA Robotics challenge, and there's many other challenges which people are competing now pretty seriously because the prize money is getting bigger. The question I have is, do you think that these challenges are helping us make progress and breakthroughs as fast as we would like? If not, if you were to define a different challenge for robotics that can help us make faster progress, what would it be?
I'll take a stab at it.
Okay.
I think challenges infuse an immediacy into things
Yeah.
that is appealing to people who are entering the field. And so there's some value to that.
Yeah.
They sometimes don't quite achieve the objective of a scientific breakthrough, but I think the objective of getting a bunch of people energized around a shared objective, particularly entrance to the field, I think can't be underestimated. There's some value to that. We have to recruit the best minds to the cause.
Yeah.
And if a challenge is what it takes, that's not all bad in my view.
It's a good thing.
But I don't think one can rely only on these challenges. They often tend to be short term. They tend to be, the clock is a little too aggressive at times. Don't permit exploration of ideas necessarily. People sort of rush to game the metric for the challenge. So there's some downsides, obviously. But I think on balance, there's some healthy mix. I've participated in some. I've stayed away from others, just for exactly these 2 reasons. So I'm sort of evenly balanced.
What's your favorite challenge?
It changes over time. So, I didn't participate in the recent DARPA humanoid challenge, the DRC. I wasn't a participant. I simply watched. It was interesting to see.
Yeah. Sometimes painful to see.
Sometimes painful to see.
Yeah.
Some good things about it, some clearly flawed things about it. So I don't think I per se have, I think many domains have interesting challenges. The aerial community has had challenges for a long time. The underwater community has challenges. And I think they all have. But I think they share this sort of common, you get a groundswell of people interested, and out of it I think some good comes. They recruit. But then I think the short-term nature sometimes can defeat the purpose, the overall purpose that you set yourself.
In some ways, I think our challenges that I see out there aren't bold enough. The one that I'm enamored with of late is the European Union's Rockin' at Home and Rockin' at Work, which I think is interesting. The Rockin' at Home is an issue where you have an elderly woman and the robot has to do 3 tasks, which are reasonable tasks, but I'm not sure they're reaching far enough. I'd like to see some bold ideas, and please. What would you like to see? I'd love to hear those ideas.
Any ideas for challenges or other questions? Sam.
So I'm Sam Adams from IBM Research as well. This is kind of along the line, both of you were talking a little bit about systems of these things, but so far we've been really focused on a single robot, right? So you got a single robot in the ocean, you got a single robot, on the station, you got a single robot in the operating room. And so what happens when you have lots of, let's start with two, and they're made by different manufacturers. They're not clones. They're not two Robonauts with exact same software and affordances, or 6 or 8. And like you said, as things get cheaper and get smaller and there's more of them, you're going to have, how do they collaborate? How do they work together? How do they even understand? You get to where you're going to have a theory of mind analog, where one robot of a different manufacturer is going to have a clue of what it can expect of the behavior of a robot from another manufacturer. And theory of mind is a very large problem in AI, but I think that this is a nice test bed for working on it. Just comments.
If Congress is any example, we know that collaboration is difficult. At one extreme, I think you have the notion of swarm robotics, which solves a particular problem of cooperation and emergent behavior. At the other level, you have what you described. You might see in an operating room where you have multiple cognitive agents that are all cooperating with one another. That's a really interesting problem. I don't have any great answers, but that's a really interesting problem. That's why we're in research, right, Sam?
Gaurav,
Yeah.
I think you work on collaborative swarms of robots.
Yeah. So I think the question was more about heterogeneity
Yeah.
in interaction. Much of my work has been, wherever it has been multi-robot, has been largely in homogeneous teams, with very few exceptions. And the exceptions have tended to be carefully scripted. So the interfaces have been carefully built so that the kind of problem he alluded to doesn't come up. So I don't think we're mature enough to deal with here's a bunch of robots that you sort of throw together, and then they can do the right thing in spite of, sort of on the fly, do the right thing in spite of differences that they may not be aware of in advance. I think that's a sort of a difficult problem and a good problem, but I don't think we quite know how to deal with that yet.
I think in the operating room, I guess I did say that the operating room is a system with a robot in the center, and I probably could have or should have said robots in that operating room, because when I was talking about sort of what was happening behind the patient, I was assuming that there were things happening behind the patient that weren't done by either people or that one surgical robot. Yes, they have to work together maybe, but then again, there are a lot of things that happen serially, where that other robot in the corner is just another object in the corner. And so there probably are some short-term solutions to this problem that allow us to get sort of partway to nirvana. But yeah, I think we will be facing a problem with just what you've described: multiple manufacturers, robots operating in parallel with each other, and we're going to have to figure out how to deal with it.
Yeah, that's a really tough problem. But I'm reminded of a TED talk by Professor Vijay Kumar from Pennsylvania, I think, where he had a group of drone robots playing the signature tune of James Bond on a bunch of instruments in like a minute or long video, which is a fascinating video. It's probably the best kind of cooperative robot scenario that I've seen.
For now, we'll just have to assume that the strongest robot wins.
Any other questions or comments? Yeah, there's one there.
I found this very interesting, but I also found it kind of drifting away from the theme that I expected, which was the theme of cognitive computing. So I wonder if we asked Watson, to what extent is this really related to Watson? What this discussion of embodied cognition. If we ask Watson, to what extent is this really related to Watson, what Watson would say?
Well, go see Pepper, but there is a spectrum of things that I imagine, with the lowest hanging fruit being you put something like a pepper on the outside of it, and Pepper becomes a user interface to Watson. It has expression, it can see you, it can interact with you, and it can dialogue. Imagine the next level up, where I have the cognition inside Watson, but now this robot moves in the world semi-autonomously. Imagine the next level where that robot acts in the world, and imagine the ultimate level where it actually is fairly autonomous in the world, cooperating with me. So this is very much part of the cognitive theme in the sense that we're sort of stepping up here. We're not going to solve the problems at IBM on locomotion and perception for robots and the like. We're going to let all the other bright people deal with that. But I think our interest is, what can you do to take a system like Watson that is deeply cognitive and put it inside a body? Where could we go with that? And that's the journey we've begun to step ourselves on.
And very interestingly, the first few applications of those services on the Watson cloud, embodied within robots, are just coming out. Pepper is one example. There's some other toys and other kinds of, very, very interesting human-robot interaction type scenarios that are coming out. But there's many other possibilities that we see in the future that many of our clients are working with. So that's, I think, a good place to end the panel. Gentlemen, thank you very much. This has been a great discussion. I think it's the beginning of yet another journey. For those of you who may not remember, IBM had a very significant robotics group about 20, 25 years ago, and over the last couple of decades, we've not been doing a lot of robotics, but I think we are now back into doing robotics in the context of this cognitive computing vision that you've heard all day long, and you will definitely see many applications of Watson and cognitive computing within the context of robotics. So I just wanted to leave you with that thought. And I have a few more closing comments to make, but thank you very much for your participation.